Question number 13. This MCQ paper, question number 13. I'll read, listen to me. When a pendulum resonates under certain frequency. So in the resonance, what will happen here? Maximum amount of energy is transferred to the pendulum, and pendulum oscillated with the maximum amplitude. So they have given three statements for a resonating pendulum. Statement A, the natural frequency of the pendulum is equal to the certain frequency. If I want to oscillate a simple pendulum or any other objects with the maximum amplitude, it should be oscillated with the natural frequency. Therefore, statement A is correct. Statement B, oscillating with the maximum frequency. No, in the resonance, the frequency may be very small, frequency will be very large, or frequency will have a medium value. It's not necessary for the frequency to be maximum. Therefore, statement B is wrong. Statement C, energy transmission to the pendulum is maximum. Yes, under the resonance frequency, energy transfer is maximum. Energy transfer is maximum. Therefore, only A and C are correct. Only A and C. Only A and C are correct. The natural frequency of the pendulum is equal to the resonance frequency or the certain frequency. Energy transmission to the pendulum is maximum. Only A and C are correct. Question number 13. Please write the answer exactly like this here. Question number 13. Some people are inside a closed room. They felt discomfort due to the sweating after some time. To avoid the discomfort, listen here. Inside a room, it is said a closed room. This is a closed room. So if people are there in a closed room, what will happen? They start to sweat. That's what say. Some people are inside the closed room. Closed room, very important that term, closed. They felt discomfort due to sweating. Sweating means liquids coming out, deposited on water, deposited on skin. Most of the time it's water. So for them to feel comfort, what should we do here? We should remove the amount of water vapor inside the room. Can you understand? We should reduce the temperature inside the room and we should remove the water vapor inside the room. Then they will feel comfort. Then they have given three methods, three things that can be done to feel comfort for the people. Allow the fan inside the room rotate fast. If a fan rotates faster inside the room, the fan cannot reduce water vapor inside the room. The sweating started mean the maximum amount of water vapor is there in the room. We should reduce the amount of water vapor in the room. Then only the sweating can be stopped. By rotating a fan with the maximum speed, it cannot be done. So it means statement A is wrong. A is wrong. B, allow the refrigerator inside the room to operate with the door open. If we open the door of a refrigerator, if we switch it on, actually the temperature will be increased. Why? What does a refrigerator do? It absorbs heat energy things inside it and give the heat energy out through the coil behind the fridge. Even in any refrigerator, you may have seen a tube is there. If you touch that tube, it is hot. Clear? So what does a refrigerator do? It absorbs heat energy inside the objects inside the refrigerator and given out. Okay? So now the fridge is kept inside a closed room. Door is open. So it absorbs heat energy from the main and give the same heat energy out to the room. Can you understand? It takes heat energy into the fridge and again given out. Then again heat is given out to the room. Therefore, B is wrong. B is wrong. So if you keep that coil, that tube inside the fridge, if you keep it outside, then it will be okay. But the entire fridge is inside the room. Therefore, it does not work. Open the door of the room. Yes. Once the door is open, water vapor and hot air will flow out. So people will feel comfort. Therefore, only C is correct. Therefore, the answer is two. Draw this figure and write the answer like this. The answer is two. I'll give you a small description for this. Below the figure, please write. Sweating is started. S-W-E-A-T-I-N-G. Sweating is started. Sweating is started when there is a lot of water vapor in the room. Sweating is started, comma, when there is a lot of water vapor in the room. When there is a lot of water vapor in the room. Clear? Full stop. Therefore, water vapor should be removed from the room for the people to feel comfort. Therefore, water vapor should be removed for the people to feel comfort. For the people to feel comfort. For the people to feel comfort. Clear? Leave a line and write. Water vapor can be removed from the room. The water vapor can be removed from the room. Water vapor can be removed from the room only by water vapor can be removed from the room only by opening the door. Only by opening the door. water vapor in the room can be removed only by opening the door. Full stop. Therefore, only C is correct. Therefore, only C is correct. Only C is correct. Question number 15. Let's try for question number 15. The transverse nature of light is oblivious by. Transverse nature can only be observed by polarization, because the reflection can be observed in both longitudinal wave and transverse wave. The best example for the longitudinal wave is sound. Sound can be reflected, sound can be refraction, interference can be observed in sound, diffraction can also be observed in sound. It means reflection, refraction, interference, diffraction. All these four can be observed in longitudinal waves as well as transverse waves. But polarization can only be observed in transverse waves. Therefore, transverse nature of light is oblivious by polarization. Right? So answer is 5. For the question 15, answer is 5. It's completed. Answer is 5. Okay, dear. Start with that, right? Polarization can only be observed in transverse waves. Polarization can only be observed in transverse waves. I think you understood the logic. Start with that, right? Polarization can only be observed in transverse waves. Polarization can only be observed in transverse waves. So, if we can observe polarization in light, light is a transverse wave. If we cannot observe polarization in a wave, that wave is not a transverse wave, because polarization can only be observed in transverse waves. Question number 16. A compound microscope has a magnification of 30. The focal length of eyepiece is 3 cm. If the final image is formed at the least distance of the distinct vision, the magnification produced by the objective is. Do you remember this equation? You remember this equation? Overall magnification or total magnification. Overall magnification or total magnification is equal to magnification of the eyepiece multiplied by magnification of the objective lens. This right? Overall magnification or total magnification equals, am I this right? Overall magnification or total magnification equals magnification of the eyepiece multiplied by magnification of the objective lens. Please write this equation first. Overall magnification of any instrument, whether it is a telescope or a microscope, is equal to the magnification of the eyepiece multiplied by magnification of the objective lens. Write it. Right. It is given compound microscope has a magnification of 30. Overall magnification is 30. Overall magnification is 30. The focal length of the eyepiece lens is 3 centimeters. So what is the magnification of eyepiece lens? E over Fe plus 1. Am I right here? Magnification produced by the objective. Let me say M of objective. Magnification of objective. D of Fe plus 1 is the magnification of the eyepiece lens. Magnification of the objective is M objective. I use a letter like that. So this is 30. This is given as 25 centimeter. Focal length of the eyepiece lens is given as 3 centimeter plus 1 into magnification of the objective. Right? You should remember these equations. Right? So now you see that centimeter cancelled out, you get only a numerical value. Take that value to the other side, so you can find the magnification of the objective. Right here, do it. Do the simplifications. This is 30. 25 divided by 3 is 8.3 plus 1 into magnification of the objective lens. 8.3 plus 1 is 9.3. This is 30. This is magnification of the objective lens. Take this 9.3 to the other side. 30 minus 9.3 equals magnification of the objective lens. What is 30 minus 9.3? What is 30 minus 9.3? Magnification of the objective is 30 minus 9 is 21. 20 minus 0.3 means 20.7. No units. Am I right there? Wait. That's a big mistake. This is not multiplication. This is not addition. Multiplication. That's a big mistake. You write whatever I write, you also write. What should be here? Multiplication, something comes beside dash. You write anything whenever, whatever I write, you also write. That should be division. So this is 30 divided by 9.3. So divide 30 by 9.3 and get the answer. Is divide and take. No units here. No units because centimeter to centimeter cancelled out. No units. If you divide this, you will get 3.22. 3.22. Right. Question number 17. When the external jaws of a vernier caliper contact to each other, the zeros of the two scales are not collinear, but fourth mark of the vernier scale collinear with the fourth mark. So it means there's a gap between the two zeros, right? The fourth vernier line coincide. So what kind of a zero error is there? The vernier scale is arranged by dividing 9 mm into 10 equal divisions. Therefore, what should be the least count? Question number 17. Least count equals L over N. Length of a main scale division is 1 millimeter. There are 10 equal vernier divisions. 9 millimeter length divided 10 equal divisions. So, 0.1 millimeter is the least count. Right? First, you write this here for question number 17. Right. The length of a main scale division 1 millimeter given. When the measurements are taken from this vernier caliper, so when external jaws of a vernier caliper contact each other, the zeros of the two scales not coincide, but fourth mark of the vernier scale collinear with fourth mark of the vernier caliper. It means it has a positive zero error. Positive zero error. What is the equation that we use to find positive zero error here? Positive zero error is the reading of the instrument. Positive zero error is the reading of the instrument. Reading of the instrument means main scale reading plus vernier scale reading. Main scale reading is zero because they say there's a small gap between zeros. They don't say anything. It is not said that main scale zero line is somewhere else. Therefore, main scale reading is zero. Vernier scale reading means least count need to coincide vernier number. Least count is 0.1 millimeter. Coincide number is 4. Therefore, the error is 0.4 millimeter. So before we measure anything, before nothing is kept between the external jaws, the instrument shows us a reading of 0.4 millimeter. Nothing is kept in between the external jaws, but instrument shows a reading of 0.4 millimeter. So this is a positive zero error. This 0.4 millimeter should be subtracted from the final reading. Whenever we measure something, we should reduce this. Therefore, answer is answer is 4. 0.4, sorry, answer is 2. 0.4 millimeter should be subtracted from the reading actually. It should be the term reading is better. So answer is 2. Answer is 2. That's it. Write them all. Question number 18. A voltmeter is connected to a circuit as shown in the following figure. The internal resistance of the voltmeter 40 ohm. The internal resistance of the battery is negligible. What should be the reading of the voltmeter? They have given us a figure like this. The battery is there and there are two resistors. There are two resistors. The battery voltage is given as 6 volt. So what will happen when a voltmeter is connected? When a voltmeter is connected, actually a current flows through its coil. That's a coil in a voltmeter. The coil has a certain resistance. The resistance of the coil is said to be the internal resistance of the voltmeter. A coil is there in a voltmeter. The current flows through that coil. Resistance of that coil is said to be the voltmeter. Therefore, I can draw the resistance of the coil. Through this coil, current flows. Right? So this is the internal resistance of the voltmeter, which is given as 40 ohms. The other two resistors, 40 ohm and 60 ohm. R1 is 40 ohm, R2 is 60 ohm. Now, instead of this R2 and R, I can use a single resistor. This is the battery. This is R1. This is the equivalent resistance of R2 and R. We take it as R3. R3 is the equivalent resistance of R2 and R. This is 6 volt. Finally, these two resistors connected in series. Finally, I can draw a single resistor instead of these two resistors. So Req is the equivalent resistance of R1 and R3. That's it. Draw the three figures for question number 18. Draw these three figures quick. Right. This is X. This is Y. Voltmeter is connected to the points X and Y. Therefore, voltmeter reading is equal to the potential difference between X and Y. This mark, and the current in the circuit is I. The current flows in the circuit is I. Mark the points X and Y and mark the current I. And mark the current I. Right. Please write RV. Look at board and write. Otherwise, you will be confused when you read this note again. Please write RV is the internal resistance of the voltmeter. RV is the internal resistance of the voltmeter. Internal resistance of the voltmeter. Internal resistance of the voltmeter. Next slide. R3 is the R3. Next slide. Next point. R3 is the equivalent resistance of R2 and RV. R3 is the equivalent resistance of R2 and RV. R3 is the equivalent resistance of R2 and RV. Right? How are they connected here? R2 and RV connected in parallel. Therefore, what is the equivalent resistance here? When two resistors are connected in parallel, equivalent resistance is product divided by the sum. Product is R2 into RV, sum is R2 plus RV. R2 is 60, RV is given as 40. R2 is 60, RV is 40. So this is 60 plus 40. I do not multiply them. If I would, I multiply 4 times 60 is 24, and there will be 2 zeros, 2400. 60 plus 40 is 100. 2 zeros can be cancelled out. Therefore, the equivalent resistance is 24 ohm. 24 ohm is the equivalent resistance between R2 and RV. So this R3 is 24 ohm. Complete here. Right. Finally, Req. This is the equivalent resistance of the entire circuit. So please write Req is the leave a line and write Req is the equivalent resistance. Req is the equivalent resistance of the entire circuit. Req is the equivalent resistance of the entire circuit. Equivalent resistance of the entire circuit. Equivalent resistance of the entire circuit. So Req equals R1 plus R3. Do a line and write Req equals R1 plus R3 equivalent resistance of the entire circuit. R1 is 14, R3 is 24. So this is 64 ohm. Req is the equivalent resistance of the entire circuit. Therefore, Req equals R1 plus R3 because R1 and R3 are connected in series. That's it. Now let me apply Ohm's law. To this Req resistor, let me apply Ohm's law. V equals IR. The voltage is 6. I is the thing that I would find. R is 64. Take 64 to this side. 60 divided by 64 is I. Therefore, I is equal to 60 divided by 2 is 3. 64 divided by 2 is 30. So this is the current in the entire circuit. Right, this one also the current in the entire circuit we have found. Is everything okay? Start point and write. Voltmeter is connected to the points. Voltmeter is connected to the points X and Y. Voltmeter is connected to the points X and Y. Full stop. Therefore, same line, same point. Therefore, voltmeter reading is equal to the potential difference between X and Y. Therefore, the voltmeter reading is equal to the potential difference between X and Y. The voltmeter reading is equal to the potential difference between X and Y. So it means voltmeter reading equal to Vxy. Vxy is I into Rxy. V equals IR. I is 3 over 32. Rxy, resistance between X and Y is R3. Resistance between X and Y is R3. So this is 3 over 32 multiplied by R3. We have found R3 as 24. We have found R3 as 24. Can you do the rest of the simplification and find voltmeter reading here, right? We can divide these numbers like this. 32 divided by 8 is 4. Am I right? 8 times 4, 32. 24 divided by 8 is 3. 8 times 3, 24. 3 times 3, 9, 9 over 4. 9 over 4. 9 divided by 4 is 2, 8. 1 remaining, 10 divided by 4 is 2. 8. Again 2 remaining, 20 divided by 4 is 5. 2.25 volt is the voltmeter reading. Who got this answer? Therefore, what should be the answer here? What should be the answer? Answer is 1, eh? Am I right? Answer is 1. Answer is 1. Answer is 1. Complete. In question number 19, a circuit is given. Look at boarding. There is a battery. This is 6 volt. There is a diode. There is another battery. Voltage of this battery is 2 volt. They are connected like this, and this is connected to the ground. So let me name this points as A, B, C, D. Actually, we want to find the current flows through the diode. That's what we want to find. No, that's a resistor also. Sorry, that's a resistor also. That's a resistor also. R. This resistance is given as 80 ohm. Draw this figure for question number 19. Right. It is given in the question that the silicon diode is connected to a circuit as shown in the following figure. The forward bias resistance of the diode is 20 ohm and the voltages across the junction diode is 0.7. So what is the junction voltage here? 0.7. How much current flows through the diode? So as the point A is connected to ground, potential of any point on the AD wire is 0. That's the first thing. And the diode can be replaced. This diode can be replaced by its, let's write these things, please write. As the point capital A, please write, as the point capital A is connected to the ground. As the point capital A is connected to the ground. As the point capital A is connected to the ground. Connected to the ground. Comma. As the point capital A is connected to the ground, comma, the potential at any point on the AD wire. As the point capital A is connected to the ground, the potential at any point on the AD wire, the potential at any point on the AD wire is 0. As the point A is connected to the ground, the potential at any point on the AD wire is 0. Next line, next point. The diode can be represented. Next line, next point. The diode can be represented by its internal resistance and the junction voltage. The diode can be represented by its internal resistance and the junction voltage. And the junction voltage. And the junction voltage. Then the junction voltage. Then the above circuit is equivalent. Then the above circuit is equivalent. Then the above circuit is equivalent to the following circuit. Then the above circuit is equivalent to the following circuit. Then the above circuit is equivalent to the following circuit. Look at what here. This is point B. The diode is represented by the junction voltage and its internal resistance. So this is the diode. This is the diode. And this is the external resistor, capital R. And this is the 6-volt battery, the ground, and this is the 2-volt battery. Look at both the 2-volt battery. So let me draw this, name the points as A, B, C, D. This is 0, this is 6 volt. This is a 6-volt battery. This is 0, this is 6 volt, therefore potential at this point 6 volt. Am I right? This is 0, this is 2 volt, therefore potential at this point 2 volt. This R is 80 ohm. This internal resistance is 20 ohm. Yeah, 20 ohm. This is 20 ohm. Junction voltage is 0.7 volt. Okay, dear? Right. So we can apply Kirchhoff law to find current. So the biggest battery is 6 volt, therefore current starts from the positive terminal of the biggest battery and current flows like this. Current starting from the positive terminal of the biggest battery, that's how you mark, and flows back to the negative terminal of the biggest battery. Mark the currents like this here. Let us apply Kirchhoff's second law, please write. Let us apply Kirchhoff's second law. Let us apply Kirchhoff's second law. Let us apply Kirchhoff's second law. What is Kirchhoff's second law here? Algebraic sum of EMF sources in the closed loop is equal to the algebraic sum of IR products. There are three EMF sources: 6 volt, 0.7 and 2 volt. 6 volt is into clockwise direction, 0.7 into anti-clockwise direction, 2 volt into anti-clockwise direction. If you take clockwise direction as positive, anti-clockwise direction should be negative. So that is 6 minus 0.7 minus 2 equals IR products. There are only two resistors, simple R and capital R. So I into 20, I into 80, I into 80. 6 minus 0.7, 5.3 minus 2 equals 20I plus 80I. 5.3 minus 2 is 3.3 equals 100I. Take 100 to this side. 3.3 divided by 100 equals I. Therefore, I equals 0.033 ampere. 0.033 ampere. Clear? So which answer is correct here? Go check whether my calculations are correct. Question number 20. The error for stopwatch that used in experiment to find the acceleration due to gravity by using simple pendulum is 0.1. So what is the error of the stopwatch here? 0.1 seconds. It means the smallest time duration that the stopwatch can be measured is 0.1 seconds. If the period is 1.2 seconds, when the time are taken for 25 oscillations, the percentage error is. What is the time? What is the time taken to complete one cycle there? Question number 20. The time period is given as 1.2 seconds. Please write this data first. The question number 20. Please write this data first. After that, let's find the time duration, the percentage error. Right now, we should write some. Let's write a few statements to obtain the answer. The first statement, please write. The time taken to complete one cycle. The time taken to complete one cycle equals 1.2 seconds. That is the meaning of the time period. Time period is 1.2 seconds. Mean time taken to complete one cycle is 1.2 seconds. Then how many cycles that they consider? 25 oscillations. Please write. Therefore, the time taken to complete 25 cycles. Therefore, the time taken to complete 25 cycles. The time taken to complete 25 cycles equals 1.2 into 25 seconds. 1.2 into 25. The time taken to complete 25 cycles, 1.2 into 25. 25 times 2, 50. 5 remaining. 25 times 1, 25. With the remaining 1/3. So what's the time taken to complete 25 cycles there? 30 seconds. Please check whether my multiplication is correct. Leave a light and write. As the time is measured for 25 cycles, as the time is measured for 25 cycles, within brackets oscillations, as the time is measured for 25 cycles, within brackets oscillations, comma, the measured time is 30 seconds. The measured time is 30 seconds. The measured time is 30 seconds. The question asks us to find the percentage error. So leave a line and write the percentage error of the time measurement. The percentage error of the, leave a line and write the equation. The percentage error of the time measurement equals least count divided by measured time. Least count divided by measured time into 100%. Let's write this equation. Therefore, the percentage error equals least count divided by measured time into 100%. Here, the least count is given as the error of a stopwatch is 0.1 seconds. It means least count is 0.1 seconds. Error of a stopwatch 0.1 seconds means the least count is 0.1. So 0.1 second divided by measured time is 30 seconds into 100%. Now you should identify that these seconds and seconds cancelled out. 0.1 into 100 is 10.0. Divided by 30, only the percentage will be there because seconds and seconds cancelled out. 10 divided by 30, when zeros cancelled out, 1 over 3. 1 over 3 means 0.33%. 0.33% is the percentage error. Therefore, which answer is correct here? Third answer is correct. Answer is 3. The third choice is correct. The third choice is correct. Who got this answer? The next question, they are talking about a fundamental frequency of a stretched string. What is fundamental of a stretch string here? If a stretch string vibrates with a one loop, right? In the one loop, it is said that the string vibrates with the fundamental mode, right? So how many loops should be there? Only one loop. Look at code. If question number 21. If a stretch string, please write. If a stretched string vibrates with a single loop, if a stretched string vibrates with a single loop, if a stretched string vibrates with a single loop, comma, it is said that the string vibrates with the fundamental mode. The string vibrates with the fundamental mode. What is the fundamental mode frequency equation here? You remember the fundamental mode frequency equation? F naught equals V over 2L. This can be written as 1 over 2L times V. V is the velocity of transverse waves along a stretched string. Velocity of transverse waves along a stretched string is given by T over square root T over M. M is mass per unit length. Draw this figure and write down this equation. Right, the question asks the frequency of the string becomes f naught over 2 at what time? I want to reduce the frequency. I want to change the frequency from f naught to f naught over 2. Right? What should I do here? Frequency should be f naught over 2. What is f naught here? F naught is v over 2L. Right? So f naught is v over 2L divided by 2. How do I obtain this here? V over 2, V over 2L, division becomes multiplication when you get the reciprocal. So then I can write this as V over 2 times L into 2 is 2L. So it means what should I do here? If I increase the length by 2, if the length is double, frequency will be f naught over 2. Am I right here? So this is length is doubled. So this is what you want, right? If the length is doubled, what will happen here? Frequency is reduced by half. Write it. Right. So what should we do, dear? The new frequency. The new frequency should be half of the fundamental. So I write fundamental and divide by 2. Fundamental is given by this equation. Once I simplify, I identify that length should be double. Then only the new frequency will be F naught over 2. Right. Let's go to the next question. Question number 22. When air blow to both end open tube by closing one end of the tube using the finger, it emits sound frequency 256 Hz. When one end is closed, what is the emitted frequency here? When one end is closed, emitted frequency is 256 Hz. When the finger is removed, the new frequency of the sound is. Right. So I have to assume that this is fundamental. I don't have any other option. So if I take this to be the fundamental, as I do not, it is not, question does not say whether it is fundamental or not. For the question number 22, draw this figure and write this F. Let me take F naught as 256 Hertz here, right? So what is the fundamental frequency equation? F naught equals V over 4A. So it means 256 equals V over 4A. Take 4 to this side. Then you get 256 times 4 equals V over L. I'll take this as equation number 1 and I do not simplify. I take this as equation number 1 but I do not simplify this. Write it here. What will happen if both ends are open? Lamai, what will happen? What will happen if both ends of the tube open? It's right when both ends of the tube are open. 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 So, this is the tube. Length of the tube remain unchanged as L. When both ends are open, fundamental mode means there will be two half loops. So now the fundamental frequency is F naught equals Lamai V over here. V over 2L. Am I right? So let me take F naught dash. This can be written as half into V over L. Am I right there? Half into V over L. Let me write here. So half into V over L is 256 into 4. 256. 4 divided by 2 is 2. 256 divided by 2 is 512. So the new frequency is 512 hertz. So which answer is correct? Second answer is correct. Second choice is correct. That's it. Question number 23 asks which physical quantities have same dimensions? What is the equation of work done here? In the question is simply saying work. What is the equation of work done? 23. Dimensions of work done. Work done is equal to force into displacement. I am not going to find force into displacement. So that is ml minus 2 into L. So that is ml square T minus 2. First of all, you find this here. Question number 23. I have found the dimensions of work done. Actually, no need to find, but let's find it. What about the moment of a coupled here? Dimensions of moment. Moment of a couple is equal to force into perpendicular distance between the forces. Moment of a couple. Moment of a couple is dimensions of force into perpendicular distance between the forces. Is right? Perpendicular distance between the forces. Moment of a couple equals one force multiplied by perpendicular distance between the forces. So dimension of force is MLT minus 2 dimensions distance of distance, that is L, dimension is L. So ML square T minus 2. Therefore, work done and moment of a couple have the same dimensions. Therefore, answer is 1. Therefore, the first choice is correct. First choice is correct. Answer for question number 3 is 3. Sorry, 1. Question number 24. It gives a displacement time graph. Question number 24 gives a displacement time graph. Look at both. Question number 24. It gives a displacement indicated by x. This is time measured by seconds. The graph has this kind of part. So what is this part? This is up to t naught. This kind of motion is there. What is this here? If a displacement time graph has a graph like this is constant, constant velocity. After that velocity, displacement not change. Displacement not change means particle is at rest. Particle or the object is at rest. So it means object travels with the constant velocity up to t naught. After that it comes to rest. So correct choice is the particle moves at a constant velocity up to a time t naught and then stops. The answer is 4. The fourth choice is correct. Answer is 4. Just draw the figure and write the answer there. It's a very, very simple question. 25. Question number 25. The moment of inertia of a body about a given axis is 1.2 kg square. Initially, the body is at rest. In order to produce a rotational kinetic energy of 1500 joules, an angular acceleration of 25 radian per square seconds must be applied about the axis of duration. What is the kinetic energy and angular velocity relationship here? Initially, object is at rest. So, do you remember this equation here? Work done equals increase in kinetic energy. Am I right? Work done is equal to torque into angular, you don't remember, angular displacement. Right? Torque into angular displacement is work done. Increase in kinetic energy means half I omega 2 square minus I omega 2 square minus half I omega 1 square. So torque, have they given us a torque there? No. So let me take torque as torque angular displacement as theta half I omega 2 square minus half I initial angular velocity is 0. We know that torque is equal to the product I alpha. Do you know? Moment of I alpha is equal to torque equals I alpha into theta equal half I omega 2 square. So what will happen to this here? This becomes 0. Can you simplify this and check what will you obtain here? You would write. Kinetic energy, final kinetic energy is given as 1500 joules. I omega 2 is given as 1500 joules. Moment of inertia is given as 1.2. Moment of inertia is given as 1.2. Angular acceleration is given as 25. Theta we don't know. Half I omega square is given as 1500. So theta can be found by this equation. Theta is equal 1500 divided by 1.2 times 25. So then we will get that theta equals 1500 divided by 12 times 1.2 times 25. 25 times 2, 50, 1 decimal point, 25 times 1 is 25 with the remaining 1/3. Am I right here? So 0, 0 cancelled out, 150 divided by 30 is 50. So rotated angle is 50. But this is not the answer. I know this is not the answer. To find the time, apply the equation theta equals omega 1 t plus half alpha t square. Apply this equation and find the time. Right here. The question asked, our time duration. Theta is 15. The object starts to rotate at rest. Initially, it is at rest. We want to find this t. Half angular acceleration is 25. This is t square. So 50 equals 0 into anything is 0. This is 25 divided by 2 into t square. 50 equals 25 divided by 2 into t square. Now so simple. Just take 2 and 25 like this. Then you will obtain that 50 times 2 over 25 equals t square. And t square here. What is t square here? Find it. Ada. 50 divided by 25 is 2. 50 divided by 25 is 2. 2 times 2, 4. So it means t square equals 4. 50 divided by 25, 2 times 2, 4. And then t equals square root of 4. So therefore t equals 2 seconds. 2 seconds. Time taken for this case is 2 seconds. Answer is 2. That's it.